Dear students, good morning to all. Today we would like to derive kinetic energy of a system of particles in terms of position vector of center of mass. Now we would like to derive kinetic energy of a system of particles in terms of position vector of center of mass. Let us do that. We have n particles, first particle, second particle, and so on. Suppose this is the position vector Ri vector, and we have the position vector of the center of mass. I can write it as R vector. Now draw the line from this one to this one. This is Ri vector prime. We know that the vector law of addition, already we had done that in angular momentum. So this can be written as Ri vector is equal to R vector plus Ri vector prime. Now differentiating with respect to time, we get dri vector over dt is equal to dr vector over dt plus dri vector prime over dt. This can be written as vi vector is equal to v vector plus v prime vector. These things are already done in angular momentum for a system of particles. So already we know that the expression for kinetic energy T is equal to summation I half mi vi square. Now vi can be written as summation I 1 by 2 vi vector dot vi vector. Now substituting these two values 1 over 2 mi, we know that v vector plus vi vector prime, v vector plus vi vector prime. Now we can use the distributive law. So this can be written as 1 over 2 half mi v vector dot v vector plus v vector dot vi vector prime plus vi vector prime dot v vector plus vi vector prime dot vi vector prime. So this can be written as half mi v square plus vi vector prime mi plus half mi vi square. So now this can be written as 1 over 2 summation I mi v square plus 1 over 2 summation I mi vi prime square plus v vector dot summation I mi vi vector prime. we left the last term is 0. Already we had seen that angular momentum for a system of particles. Let us do this again also. So last term is summation I mi vi vector prime. This is equal to, we know that velocity is equal to rate of change of displacement. So d over dt summation I mi ri vector prime. So ri vector plus ri vector prime is equal to ri vector. So now substituting this in equation, summation I mi ri vector minus r vector d over dt of. So this can be written as, we know that this can be written as summation I mi ri vector over summation I mi minus total mass of the system m into r work. This is the definition of center of mass. This term is definition of center of mass. So this can be written as m r vector minus mr vector. So this will be 0. So the kinetic energy of a system of particles is equal to half summation I mi vi square plus half summation I mi vi prime square. So the kinetic energy of a system is equal to kinetic energy of center of mass plus the kinetic energy of the system with respect to center of mass. Kinetic energy of the system with respect to center of mass. So in this session we have proved the total kinetic energy of a system of particles is equal to the